So here in this question, the question was which change is a reduction? Reduction means it's a gain of electron. And when reduction happens, the charge should decrease. That's why it's called reduction, like decrease. So if it's plus 2, it take 1 electron, it should be plus 1, not plus 3. That's why it is wrong. This is equation is correct, but this is not reduction, this is oxidation. It's a loss of electron. Equation is true, but this is not reduction, it's oxidation. When iron 3 gain electron, it become iron 2, that's reduction. And you can see the charge decreases. And this equation is not true because it should be plus 4. So the B and C equations are correct, but equation B is for oxidation, so equation C is the reduction. Which row describe how the energy of the collision between the particle changes when concentration and temperature are increased? If we use more amount or higher concentration, how the energy between the particle is affected? What could be the answer? Question 5. How a concentration affects the speed of a reaction? The concentration does not affect the energy of the collision. Number of collision will change, but energy at which the particles are colliding, that will not change. Like if I use, say I was having 4 particles of reactant and I use 10 particles of the reactant. If I use the same temperatures, if temperature is not changed, the energy of the collision will be same. So no change in energy of the collision. And as I increase the temperature, the energy of the collision will also change. So with concentration, the concentration does not affect energy of the collision. Number of the collision will change. If this was number of collision, then both should be increase. But the term is energy of the collision. So energy of the particle depends on the temperature, not depends on the amount. That's why energy of the collision here, if the particles are having energy of 2 joules to collide, the other one also energy of 2 joules to collide. But if I carry out the reaction at higher temperature, then particles will have more energy. That's why C will be the right answer. Is it clear? Which row explain increased temperature, increased rate of reaction? Tick means that's right, that will happen, and cross means that will not happen. Everyone should try to participate, because even if you say a wrong answer, that's not an issue. The thing is, you should try to answer so that you will have a better understanding of the topic. Wrong answer is not an issue at all, because this is not the test. This is just to clear the doubt and clear the concept related to the topic I taught. So A is the right answer, because when we increase temperature, particle have more collision and the particle will have more energy as well. A student was investigating the reaction between marble chips and dilute hydrochloric acid, which change slow down the reaction. Keep in mind, in the question they mentioned slow down, not speed up. which will slow down the reaction. A is the right answer because we decrease the temperature, so less often they collide. We decrease the concentration, so less collision between the particle. And surface area, if the same question was, surface area should decrease, but if the same question was, instead of surface area, they use the term particle size. So if the particle size is there, the particle size should increase, like we should use lumps. Large particle size is small surface area. Small particle size, large surface area. There's a fifth, that's right. The rate of a reaction between magnesium and excess of hydrochloric acid was followed by measuring the mass of a magnesium present at a regular time interval. Two experiments were performed. Both experiments used 0.1 gram of magnesium ribbon. Acid in experiment was less concentrated than experiment 2. Which graph shows the result? So first you have to identify which one will be faster. Acid in experiment 1 is less concentrated. So experiment 1, less concentrated means experiment 1 should be slower than experiment 2. And mass of magnesium, because magnesium is a reactant, so its mass should decrease when this reaction will occur. So experiment 1 should be slow and experiment 2 should be fast. So you can see here, experiment 1 is less steeper than experiment 2. Why C and D cannot be an answer? Because magnesium is a reactant. Reactant mass will not increase during a reaction, its mass will decrease. So either A can be answer or B. But B will be answer if 2 was slower. A is answer because 2 is faster. Is it clear? Which statement explain why a coal dust form an explosive mixture with air? Like coal mines, fine particles of coal are there. If a small spark can ignite or burn these particles. So why the coal dust form an explosive mixture with air or can burn easily with air in the presence of air? Because the coal dust has a large surface area because it's a dust. Dust means fine particles are there. Fine particle, large surface area, so it can burn easily. Question 20. Zinc granules are reacted with excess of hydrochloric acid. The volume of hydrogen given off was measured at different time. The results of are shown on a graph labeled experiment 1. The result of second experiment is also shown and labeled experiment 2. Which change to the condition was made in experiment 2? Experiment 2 is slower than experiment 1. What change is done in experiment 2 to slow down? So because experiment 2 is slower, concentration of hydrochloric acid was decreased. A was the answer. Size of a granule decrease. If we decrease the size, means we increase the surface area. So it will be faster. Surface area of zinc granule increase, that's also increase the rate. Temperature increase, that's also increase the rate. But we want to decrease the rate, that's why A is the correct answer. Is it clear? In an experiment, nitric acid was added to excess of marble chips and the volume of carbon dioxide formed is measured. The experiment is repeated using smaller marble chips and all the conditions are same. Which statement about the second experiment is correct? So the only thing which affect the energy is the temperature. So only thing which affects is the temperature. So they have more collagens, but with the same energy because condition, the temperature also remains unchanged or same. An experiment X is carried out between a solid and a solution using apparatus as shown. The volume of the gas given off is measured at different times and the results are plotted on the graph. In the second experiment Y, the surface area of a solid is increased but all other factors remain same. Which graph shows the result of experiment X with Y? What could be the right answer? All other factors remain same, only we increase the surface area for experiment Y. So experiment Y should be faster. That's why B is the right answer. Then another factor which affects the speed or the rate of the reaction is a catalyst. The catalyst will lower the activation energy. So reaction can occur with low energy particles. So what catalyst will do, they lower the activation energy or decrease the activation energy. So reaction can occur with low energy particles. Example, you have two reactants A and B. And the energy of A and B is 150 joules. But the minimum possible energy for which the reaction start, that's the activation energy. Activation energy is 200 joules. So what will happen? This reaction will start, occur or no? Is there any reaction between A and B? Energy of A and B is 150, the total I'm saying. But minimum possible energy they required for start of the reaction is 200. Will the reaction occur? So there is no reaction at this energy. But what happened? Catalyst lower the activation energy. How the catalyst lower the activation energy? They reduce the strength of the bond within the reactant particle. So if we use a catalyst, example, I'm using a catalyst, say iron I'm using as a catalyst. Transition elements are better catalysts or having a catalytical activity. So I use iron here. What this iron will do, if you use catalyst, the catalyst will decrease the bond strength within reactants. So activation energy will decrease. Because how a reaction occurs, reactant, the bond should break and then it will form a product. So when we use a catalyst, what these catalysts will do, they trap the reactant molecules at the surface. So this catalyst, like example, I'm using iron as a catalyst. So this iron will trap the reactant molecules at the surface. When it traps the reactant molecules at the surface, the bond strength or bond within the reactant molecule will decrease. So the same reaction, example, the molecule has 150 joules, originally same 150 joule. But what happened when we use a catalyst, iron as a catalyst, it reduces the strength of the bond within the reactant particle. So the same reaction activation energy will be lower. So example, it is 120 joules. So as the activation energy is lower, this now what happened? The particles have 150 and their bond strength is weaker. So bond strength is weaker because of catalyst. So bond can break easily and it can form a product. But without a catalyst, the bonds within the reactant particles are stronger. So it is difficult to break this bond. That's why we need a sufficient amount of energy or higher activation energy. So using a catalyst, the catalyst lowers the activation energy. So if we sketch a graph, for rate of the volume of a product, the amount of product will be same. One is with catalyst, another one is without catalyst. So this is with catalyst, which is faster, and without catalyst, it will be slower. But catalyst is a substance which does not used up during a chemical reaction. So example, if I use 10 grams of iron before the reaction, in the beginning of the reaction, after the reaction, the mass of iron will be more than 10, less than 10, or equal to 10. If before the experiment, in the beginning of experiment, I use 10 grams of iron. When the reaction completed, how much iron I should left with? More than 10 gram, less than 10 gram, or equal to 10 grams. So it will be equal to 10 gram because the catalyst does not take part in a chemical reaction. So catalyst does not consume during a chemical reaction. It remains unchanged. So if in the beginning it is 10, after it should also be 10 gram. Is it clear the concept of using a catalyst? So what catalyst will do? Catalyst will lower the activation energy. How it lower the activation energy? It reduces the bond strength within the reactant particle so that the bonds can break easily at low energy, so the reaction can occur at a faster rate. Any doubt in this? and most of the transition elements are used as a catalyst. A very common question you will find in exam, they ask, plan an experiment to show certain substance as a catalyst. So if you want to plan an experiment to show substance X is a catalyst. X, the reason why I use X here, it means it can be any substance according to the question. So there's a variable, like it can vary. So substance X is a catalyst we want to show. The common lab apparatus which we use to show a substance is a catalyst is hydrogen peroxide. Hydrogen peroxide, it is not a stable compound. Even at room temperature, hydrogen peroxide will dissociate into water and oxygen. Hydrogen peroxide is a liquid, water is also a liquid, and oxygen is a gas. So when this reaction occurs, what I will observe? What is the observation when this reaction occurs? What I will observe? If a gas is given off during a chemical reaction, so we'll see bubbles. So there will be bubbles of colorless gas, but because the reaction is very slow, so slow formation of bubbles. But if I use the catalyst, so hydrogen peroxide, and I use a substance as a catalyst, because catalysts are only altering the rate or the speed of a reaction, does not affect the product. So we write the catalyst name on the arrow, does not write either on a reactant side or a product side. So example, a substance X is a catalyst. The product will be same. Product is water plus oxygen. But what will be the observation? If a substance is a catalyst, then we'll observe rapid formation of the bubbles, because catalysts speed up the rate of the reaction. So how you can plan this experiment, how you can show that the substance is a catalyst? Because for a substance to be a catalyst, it should alter the rate of a reaction and should not be consumed or no change in a catalyst. So the steps to plan this experiment, first we will measure mass of X. So using a balance, it's better you mention whenever you're planning experiment, it's a 6-mark question. So you should use specific apparatus for each quantity. So measure mass of X by balance. So first we measured the mass of substance X by placing it on a balance. For example, this is a balance. And you place substance X on this balance. Then we will fill the conical flask with 10 cm cube of, it can be any quantity, but it should be measurable quantity with a specific apparatus. So fill the conical flask with 10 cm cube of hydrogen peroxide. To fill this 10 cm cube of hydrogen peroxide, I can use a measuring cylinder. So fill conical flask with 10 cm cube of hydrogen peroxide by measuring cylinder. This is a conical flask, and we fill this flask by the help of measuring cylinder. And we took hydrogen peroxide. For example, 10 cm cube of hydrogen peroxide was there, and this 10 cm cube, with the help of measuring cylinder, we transfer that into a conical flask. So conical flask will have 10 cm cube of hydrogen peroxide. Is it clear till now? Take the screenshot, so I'll move on to the next slide. Then after filling up this with a using a measuring cylinder, we fill the conical flask with hydrogen peroxide. Then the third step, we will add substance X to conical flask. By the help of, so if we want to add a solid to a reaction mixture, so we can use a spatula. So add substance X to conical flask by the help of spatula. So in the conical flask, we were having hydrogen peroxide. Already there is hydrogen peroxide. And we add substance X now inside by the help of spatula. But the thing is, because we want for a substance to be a catalyst, it should alter the rate or the speed of the reaction. So here in this experiment, hydrogen peroxide on the dissociation, it is giving a gas. So what we can do, we can place a gas syringe and record volume of gas in unit time by help of stopwatch. So gas syringe is used to record the volume and stopwatch is for time. So then we'll place a flask which consists of a reaction mixture, hydrogen peroxide, and a substance which we want to show is a catalyst. And then we connect a gas syringe to this. they asked to draw these figures as well, so you have to practice. Here's a stopper or a bung, a rubber bung, and using a stopwatch at a certain time interval, we are measuring a volume of a gas given off. So we place a gas syringe and record volume of a gas in unit time by the help of a stopwatch. Now, because a substance is a catalyst, it should alter the rate and the mass of the substance should not change. Then what we will do, we will filter, because we want to remove substance X from this mixture. So we will filter and dry X from the mixture. Then reweigh, means we'll wait again. Then repeat the experiment without substance X. And what is the conclusion? How you conclude this experiment? If substance X change the speed of reaction and its mass remains same, unchanged, so it is a catalyst. So this is a paper 6 question, a 6 marks question, that plan an experiment to show a substance X is a catalyst. So I'll just repeat. Look what we did. A common lab apparatus, we use hydrogen peroxide. Hydrogen peroxide is a unstable liquid. Even at room temperature, it can dissociate or decompose into water and oxygen. So this is a common liquid which is used for identifying whether a substance is a catalyst or no. So we add this so if we want to show a substance X is a catalyst, so we measure the mass of substance X. Then we take 10 cm cube of hydrogen peroxide transferred into a flask. Then we add a substance X, we place a gas syringe, record the volume of the gas with respect to time. Then we will filter and dry X from the mixture and then reweight again or measure the mass again. Then repeat the experiment without substance X, because we should know that whether it is altering or changing the speed of a reaction. So one experiment is with X, another experiment is without X. If mass of X does not change and it alters the speed of the reaction, it means substance X is a catalyst. Is it clear? This experiment. So this is a common experiment. You will find it is repeated many times in different manners. Example, like if they say plan an experiment to show manganese 4 oxide is a catalyst, copper oxide is a catalyst, copper is a catalyst. So only in place of X, that's why I use this term X. In place of X, you will just change the compound. The gas is oxygen. In step 5, start your timer, record the amount of. Yes, you can mention, but the gas is oxygen. Afif. Others, what you mentioned is correct. Like measure the volume of a gas. You can mention that. Like measure the volume of the gas or time taken by gas volume to be 7 cm cube or 2 cm cube or 5 cm cube. That can be mentioned. So either you make a volume fix and time, or if you make a time fix and then, like example, you can also say volume of a gas given off in 2 minutes. That can also be compared. Better make a time fix, because it's easy to make a time fix rather than volume fix. Maybe you think like 7 cm cube of gas should be there, but maybe experiment will not produce same 7 cm cube. So you will not reach 7 cm cube. Is it clear, this whole experiment? Any doubt? Planning of experiment? Yeah, which page you want to take the screenshot? So if the question was plan an experiment to show manganese 4 oxide or copper oxide or copper 2 oxide is a catalyst. So the same question, all the parts in place of X, I will replace with copper oxide. That's it. So example, so what I will do, I'll measure the mass of copper oxide by balance. Instead of saying X, I will say measure mass of copper oxide by balance. Fill the conical flask with 10 cm cube of hydrogen peroxide by measuring cylinder. Then add copper oxide to a conical flask by help of spatula. Place a gas syringe, record the volume of a gas in a unit time. Then filter and dry copper oxide from the mixture and reweight. Repeat experiment without copper oxide. If copper oxide changes the speed of reaction and its mass remain unchanged, it shows that the copper oxide is a catalyst. So same experiment, but without, just change the letter or X with the substance which is given to you. Is it clear? There will be link after this.